let's talk about how to find average rate of change over an interval of values for x. So we're going to be looking at a function f of x, starting at x equals a and ending at x equals b. So for an interval, you can think of this as going from a to b, where we're including those endpoints. And our average rate of change will be the difference in outputs over the difference in inputs. And if that sounds familiar, it should very closely, if not exactly, relate to how we calculate slope. That's really what we're doing here, is we're calculating the slope between 2 points. It's just we're working with function notation, and in the context of a problem, we can describe this as average rate of change. Okay, so with this table, what we're seeing is information about the average cost of gasoline in dollars based on the year. So using the data in the table, find the average rate of change from 2007 to 2009. So we have these input and output values. So if I want to look at this average rate of change, which for short we can write that as AROC, what we'll do is we'll calculate the outputs. So let's say we take the cost in 2009 minus the cost in 2007, and we're going to divide that by the difference of 2009 minus 2007. So we're going to go 2.41 minus 2.84 all over 2, and then we'll throw that into a calculator, and we'll get an average rate of change of negative 0.215. So what that tells me is that between 2007 and 2009, gas price decreased on average by 22 cents, we'll round that, per year. So some things in the wording there. We're talking about an interval of those years, specifically 2007 to 2009. We saw an overall decrease because of that negative right there. And then we do want to say that it's happening on average, because this is an average rate of change. And then by this cost per year. And if you're wondering about the units of what goes first per what, if you look at our setup here, it always goes numerator, which in this case is dollars, and then our line represents per, and then down here we had year. So my rate would be dollars per year there. Okay, let's go ahead and find the average rate of change between 2005, so all the way out here, to 2010. Okay, so our average rate of change, let's take the output from 2010, so that's a 2.84, minus the output from 2005, which is a 2.31, over 2010 minus 2005. All right, and then we'll put that in a calculator. 2.84 minus 2.31 over 5 for a 0.106. So in a sentence, I would say between 2005 and 2010, gas prices increased, because it's positive, on average by, and this would be like 11 cents per year. Okay, so there's a scenario with tables and finding the average rate of change. Let's say we just had a function without any sort of context here. So if I want to find the average rate of change, I want to take h of our output of 3 minus h of -2 over 3 minus -2, and make sure you have those parentheses there to show that in the denominator we have minus and negative, so it'll end up being addition. Now, if you want, you could calculate these separately. So like I could go looking for h of 3 by going 4 times 3 squared minus 3. So 4 times 9 is 36, minus 3 is 33. So now I know I can substitute 33 for h of 3. And then we'll also look at h of -2, which is 4 times -2 squared, minus 3, which is a 4 times 4 is 16, minus 3 is 13. So we can make the substitution of that 13 where I have h of -2. So we'll go 33 minus 13 over a 3 plus 2, which is 5. So that'll be a 20 over 5 for a 4. We don't have any units here, so we don't need to make a sentence, but that's how we'd find our average rate of change. All right, let's go back to a word problem here. So we have the function b equals n of t, represents the number of birds, b, in thousands migrating through Washington t years after 1990. So explain the meaning of n of 7 equals 9.2. So the 7 is representing t, which is years after 1990. So what that's telling me is we're in 1997 there. And then this value for 9.2, that's our value for b, which is the number of birds in thousands. So what I could say is in 1997, 9,200 birds, let's see, migrated through Washington. Okay, so if n of 6 equals 6.1, find the average rate of change from t equals 7 to t equals 9. So we're looking at n of 9 minus n of 7, and we'll be taking 9 minus 7 in the denominator. So n of 9 is 6.1, and then we're going to subtract away 9.2, and we're going to divide that by 2, which we will find that to be a negative 1.55. So we're looking between 1997 and 1999. So let's say between 1997 and 1999, the number of birds migrating through Washington, birds migrating through Washington decreased on average by, and that would be number of birds per year. Again, in the numerator we have birds, division is our per, and then in the denominator we were talking about year. So that would be 1,550 birds per year. Okay. So that's how we could form our sentence there. Again, increasing, decreasing is based on positive, negative. We're talking on average. And then we can form our rate by looking at how we set up our fraction there. Okay, last scenario here is to see what are we doing in terms of a graph. So here we have a nice polynomial graph going all over the place. And we're going to look at the interval from -3 to +1. So at x equals -3, our function is right here. And at x equals +1, we're right here. And when I'm looking for average rate of change, it's like I'm looking for the rate of change just between those 2 points. So the idea is between them, sure, we went up and down and then up again. So there was all sorts of change occurring. However, on average, it's just a matter of getting from this first point to our second point there. So let's give coordinates here. So that's a -3, 0. And here we're at a 1, and let's go ahead and estimate that as a 4. So if I want to calculate the average rate of change, I'm going to take the difference in the y values, so how about 4 minus 0, over the difference in the x values, 1 minus the -3. And that should be a 4 over 4, which is equal to 1. And that should be our slope of the line here, which is difficult to see because of the scale of the y-axis being in 5s. But if we had a nice 1-by-1 grid going, we should be able to see a nice slope of 1 for that red line that I drew there. So there's some different applications of average rate of change.